Good morning, everybody. Happy Monday. Welcome to our final unit of this online learning. This is solving systems of equations, and it's a really short unit. We're going to finish it in just over a week. So I've posted the weekly schedule from now till the end, where this is going to take us to about Wednesday of that final week. And then the last 2 days, we will figure out how we can wrap up and how we can and catch up. So that's kind of still to be determined. But this unit is going to take us till the middle of next week. Then we're done. Okay, so yeah, let's jump into this. It's a fairly short unit, and we're going to jump into the first one. You're going to need your graphing calculator for this one, so get it out and get ready to go. Page 613, jumping into our new unit, which is solving systems of linear equations. And what we're going to do is we're going to dive into what that actually means and what it means to solve them. And through the unit, we're going to look at 3 methods. Okay, those are called graphically, substitution, and elimination. Today, we're looking at graphically, which you can probably guess what that technique is going to look like. Okay, so here's an exploration. The Smith family and the Harper family are going to a book fair raising money for charity. Mr. Smith pays entry for $11 for 3 adults and 1 child. Mrs. Harper pays entry of $12 for 2 adults and 3 children. We can determine the cost of an adult ticket and the cost of a child ticket by forming 2 linear equations and graphing them. Okay, so what we're going to say is a let statement, which is kind of establishing variables. So we're going to say let X, that amount of money, is the adult ticket. Okay, so X equals adult. And then Y is the price of a child's ticket. So when I'm talking about X's and Y's, I have some context. Okay, so then it says the information about the Smith family can be modeled by 3X plus Y is 11. Right, because they paid for 3 adult tickets, 1 child ticket, and they paid a total of $11. The Harper family, 2 adults and 3 children, that added up to $12. Okay, it says draw the graphs of those equations on the grid without using technology. All right, so I still don't actually know what it means to solve a system of equations, but I have a system. Here's one equation, here's another equation. Together, those would make up a system. I'm not really sure what it means to solve, but let's graph. Okay, so I'm going to take the first one, which was the Smith family. 3x plus y equals 11. That's not even general form. That's just some random form. To me, the easiest way to graph a linear relation is to convert it to y equals mx plus b, which would be y equals negative 3x plus 11. And what I'm going to do is I'm going to call that y1. Like on my graphing calculator, I have y1, y2, y3, y4. I'm going to call that y1. Okay. And graphing that one, slope is negative 3. Your y-intercept is 11. All right, well, there we go. 11, and then a slope of 3. So down 3 over 1. Down 3 over 1, there's my point. Down 3 over 1, there's my point. And I'm going to try to be as accurate as possible with this graph because I'm doing it by hand. So I'm going to make as many points as fit. Down 3 over 1, down 3 over 1. Okay, I ran out of space. And now I'll make my line, which will not be perfect, but at least I have those dots to reference. Okay, yeah, certainly not perfect, but whatever, we'll call that good. We'll call that good, okay? All right, next one, which is 2x plus 3y equals 12. I can graph that one as well, and I'm going to do basically the same thing. Move the 2x over, rearranging to y equals mx plus b. Negative 2x plus 12. This one, though, I have to divide away a coefficient. So I divide both sides by 3. I get y equals negative 2/3 x plus 4. 12 divided by 3 is 4. And I'm going to call that y2. Not for any particular reason in this question, but if it were to be my graphing calculator, here's my one y equals, here's my second y equals. Okay, so slope of negative 2/3, b value or a y-intercept of 4. Okay, so I'm going to put that there. Down 2 over 3, down 2 over 3, down 2 over 3. Oh, hey, that kind of shares the same point. Down 2 over 3, there's another one. There's another one. And then again, I'll try to make my line as good as possible. Not great, but whatever. The reason I put as many dots as possible is because I wanted to see something curious here. The blue point and the purple point are actually the same point. Okay. The graphs of the equations intersect at a point. Yeah, that's just what I talked about. Oops, I didn't really want to draw that circle. State the coordinates of this point. So that is, okay, the point of intersection, POI. Okay, so instead of writing point of intersection, I might just write POI is 1, 2, 3, 2. 3, 2. All right. And in the context of this question, okay, well, that is the point where both lines have the same values. Okay, for the purple line has x of 3, y of 2. And for the blue line has x of 3, y of 2. Every other point on the blue line is not on the purple line. This is the only moment where they share a point or they share x and y values. Okay, we're going to explore it later. That point of intersection is called the solution to the system. Okay, so what it allows you to do is say, okay, well, the blue line, that's one context. The purple line, that's another context. When are they actually the same? That's what I'm looking for. Okay. All right. Let's actually put some context to it, and let's put some real definitions behind things. Okay. In the explanation on the previous page, we worked with the equation 3x plus y equals 11. And it says there are many values of x and y which satisfy this equation, right? What that means, a point satisfies an equation if it's on the line. The x and y, I plug them in and they work, right? It's actually on that line. The other equation, okay, 2x plus 3y equals 12, right? Tons of points as well. There are an infinite amount of points on that line. All of those points satisfy the equations. Okay, if we consider both of these equations, so now I'm talking about a system. I'm talking about you have both of these equations together. There was only one moment where I could find a point that would be on both of the lines. And it happens at x is 3, y of 2. Okay, and the reason for that is it satisfies each equation in the system or both equations in the system. Okay. So if I ask you to solve a system, what I'm saying is, hey, find the point, find the x and y that work for both lines. That would be a point on both lines, or we call that the point of intersection. Okay, so let's do an example. All right. I have two lines. Okay, I'll color one. This one's blue. Okay, this one's purple. And I'm saying, okay, I need a point that works for both equations. So let's say I pick this point up here. Yeah, that's on the blue line. It satisfies the blue equation, but it's not on the purple line, right? Maybe I pick one from the purple line down here. Satisfies the purple equation, not the blue one. The one I'm looking for is right here, the point of intersection, right? Where x would be 2, y would equal -1. Adds an ordered pair, 2, -1. All right, that is what it means to satisfy both equations. The point lines up on both lines. So solving a system graphically is the easiest thing. We graph them and we find where they cross. Okay, we graph them and we find where they cross. All right, so let's do that. It says you have 2x plus y equals 2, x minus 3y is equal to 15. graph the system, and then state the solution. Okay, well, I'm going to start with the first one. 2x plus y equals 2. If I want to graph that, it's pretty easy for me to rearrange to y equals mx plus b. Y equals negative 2x plus 2. And I'm going to call that y1, which when we do use our technology, when we do use our graphing calculator, I'll call 1y1, 1y2. All right, graphing that. Y-intercept of 2, slope of negative 2. So down 1, down 2 over 1. There's a point. Down 2 over 1, there's a point. And if I'm ever trying to solve a system by hand, it takes a bit more time, but I'm going to label as many points as possible on the graph, because when I draw my line, especially on this screen here, it's not perfectly straight. But if I label the points, then I know where the specific points are. Okay, I can work backwards, up to back 1, up to back 1. All right, so I've got all those points. Now I'll try to connect a line. Probably won't be perfect. Oof. Whatever. But at least I have my points to reference. So even though my line, if I had a real ruler, I think it would be a lot better. Okay, next one. X minus 3y equals 15. Let's rearrange and graph this one. Negative 3y equals negative x plus 15. And divide away that coefficient. Okay, divide away negative 3. Y equals positive 1/3 x, negative divided by negative, positive 1/3 x minus 5. Okay, and that's y2. All right, y-intercept to negative 5, I can graph that. And then I am going up 1 over 3, up 1 over 3. Well, automatically, hey, there it is. That's my point. Then maybe I do a few more. Maybe I go back the other way and I connect my line, but I can actually already see, oh, that was horrible. I'm just going to try that again. Oh, no. One more try. Pretty good. Okay. I can actually already see my point of intersection. It's right here. That is the point that satisfies both equations. Okay. And that point is 3, negative 4. And I state it as a coordinate pair. Okay. All right. C, what it asks us to do is verify, verify that the answer is correct. So verifying is something you did in grade 9 for solving equations. And what we're going to do is we're going to take both equations and test this value. Okay, so I go back to the original version. 2x plus y is equal to 2. And I'm going to plug in this 3 and this negative 4. All right. And I'm going to put this line down. So 2 times the x value of 3 plus negative 4 is supposed to equal 2. So I'm not rearranging. I'm not doing any algebra. All I'm doing is simplifying the left and simplifying the right. So on the left, 2 times 3 is 6, plus a negative 4, that would just be minus 4. On the right-hand side, it's just a 2. So it's just going to carry all the way to the bottom. I have to make one more obvious statement, 6 minus 4, that simplifies to 2. And now that I see 2 is equal to 2, I say left side equals right side, and I put a little check mark. So what I did is I proved that 3, negative 4 satisfies or works for the blue line. If it didn't, my left side and my right side would be totally different numbers. Okay? It's not good enough just to check my one equation, though. I also have to go back to x minus 3y equals 15, and I plug into that one. Okay? And I put a line down. So I plugged in the x of 3, the y of negative 4. 3 plus 12, that's supposed to equal 15. All right, you get the very obvious statement of 15 equals 15. Left side equals right side. So I have verified my answer. The point 3, negative 4, it satisfies this, and it satisfies this. So algebraically verifying, that has nothing to do with solving. That's me justifying to myself and proving that I know it's a solution. So this is almost a way for you to double check your answer. I got this. Let's see if it works. So I might ask you to do this, but I won't always ask you to verify. Okay, now let's get to the good part. I can use my graphing calculator to do this. So on your page, it lays out all the instructions. We actually know how to do this. So I'm going to skip that, and you could go back and read it if you wanted some help. But let's just use our graphing calculator. Okay, 3x plus y equals 11, 2x plus 3y equals 12. If I am going to graph this, they need to be in the form y equals. Okay, and we actually did that on the first page. So I'm not going to redo it. I'm just going to write them. The first one we called y1, and it was negative 3x plus 11. And if you want to see the work for that, just go back to the first page. Okay. The other one, we called that y2. It's our second equation. And that was negative 2/3 x plus 4. Okay. So there we go. That's A. I rearrange them to slope y-intercept form, or I rearrange to y equals. Now I can put those in my calculator. Okay, so I start here. I press y equals. That's the only place I can enter something. First one, negative 3x plus 11. That's why I called it y1. All right. y2 is negative 2/3 x. So I'm going to go bracket, negative 2 divided by 3 bracket, then my x, and then I can do plus 4. And to start graphing, I'm going to go zoom 6 or zoom standard. There's my first line. There's my second line. Looks pretty similar to the picture that I drew. Okay. It says state a suitable window that shows the x and y intercepts and the point of intersection. Okay, well, my window's pretty good. The only thing I need to do is make this a little higher. So instead of my y maximum going only to 10, let's just boost it to 15. Perfect. So your x's were just the normal, negative 10 to 10 with a step of 1. Your y's, negative 10 to 15 with a step of 1. Just slightly modified. Okay. Now it says solve the system equation using the features of your calculator. And then we're going to confirm that we get the same answer as above. So what that means is find the point of intersection. Find where these things cross. And we've actually done this before. I'm going to go to calc, which is above trace. So second calc, scroll down to 5 for intersect, or I could just press the number 5. All right, on the first curve, yeah, I'm on the blue line. That's one of the ones I want to know where it intersects. Enter. In the second curve, it automatically jumps, and I can move my arrow side to see where I am. I jump to the other one. Yes. Make a guess. I'm going to go close to where I think the point of intersection is and hit enter. And I get the point. Point of intersection, 3, 2. That is my answer. And if I recall correctly, that's the answer we got on the first page. Okay. It says confirm the amount of the entry fees established in the exploration. So it is wanting me to verify, and I'm going to do that with the original equations. Okay. 3x plus y equals 11, which is, okay, so 3 adult tickets. 3 times 3 plus 1 of the child tickets is supposed to equal 11. 9 plus 2, does that equal 11? Yes, it does. Left side equals right side. Hey, so the prices, I'm saying an adult is 3, a child is 2. Seems to work. Okay, remembering this was adult, this was child. And then let's try the other equation. It said 2 adults and 3 children. That was supposed to equal $12. 2 times 3 plus 3 times 2. That's supposed to equal 12. So 2 times 3 is 6. 3 times 2 is 6. Oh yeah, 6 plus 6 does equal 12. Left side equals right side. So this point, 3, 2, satisfies both of the equations in my system. So I know it's correct. All right, I know it's correct. And notice when I verify, I'm going back to the original form of the equation, the original way that they gave it to me, not the rearranged one that I found, because maybe I made a mistake rearranging. Okay, so go back to the very first form. All right, Moving on, let's solve a little bit more with our graphing calculator. Says if it decimal value. Okay, again, okay, you can read this. I'm going to show you something cool we can do with our calculator as we solve. All right. Solve the following system of equations using a graphing calculator. 6a plus 7b equals 5. 3a equals 14b. So what I'm going to do to start is I'm going to say a normal coordinate pair would be x comma y. Let's just say what the letters mean. So if I'm dealing with a's and b's, let's just stick with the idea of alphabetical, a then b, x and y. Okay, so for the first one, 6a plus 7b equals 5. I always rearrange to y equals. So in this case, I'm going to rearrange to b equals. Okay, which would be not a lot of room to do this. Okay, 6a, I'll just do them on the side. 6a plus 7b equals 5. Subtract the 6a, subtract the 6a. Man, I don't have a lot of space. 7a equals negative 7b, my goodness, equals negative 6a plus 5. And then I divide by 7. Okay, so I'm dealing with some fractions. b equals negative 6/7 a plus 5/7. And in my calculator, here's where I'm going to make the switch. Because that's going to be y1 equals negative 6/7 x plus 5/7. Okay, so I'm working with a's and b's, but on my calculator, it's going to need to be x's and y's. For the other one, 3a equals 14b. I need to rearrange that to b equals to make sure it's the same as the other one, which would be a divide by 14, divide by 14, fraction 3/14 a equals b, or I know I could write that the other way. b equals 3/14 a. So y2 equals 3/14, not a x. All right. And you can see how much I'm kind of like misspeaking and saying the wrong letter. That's why I wrote this above, so I can always check. Okay, a's and x's, that's really the same. B's and y's, that's really the same. I just need to make them x's and y's for my calculator. Okay, let's graph it. Go to my calculator. Go to y equals. Hit clear, y1, bracket, negative 6 divided by 7, close the bracket, x plus bracket 5 divided by 7, bracket. Okay, great. y2, another fraction, 3 divided by 14, bracket. Make sure you're closing that bracket. Then I hit x. And let's just go back to Zoom standard, Zoom 6. There's the first one, there's the second one. Good. As long as I can see the point of intersection, I'm happy. Let's find that. Okay, we're going to calc again. So second calc. Scroll down to 5 for your point of intersection. First curve, I don't really know where I am, so I'm going to go left or right with my arrows. Oh, I'm on the blue one, so yep. Second curve, I jump to the red one. Good. And make a guess. I think it's right around there. And I get 0.6 repeating for my x and 0.1428571 for my y. Okay. Well, it says to list exact values, which means I can't just write the decimals. I'm going to have to write them as a fraction. Okay. So my answer, just for the record, I'm going to write it over here. X was 0.66666. Y was 0.14285. So if I just asked for a decimal, you could absolutely plug that in. Okay, you could absolutely plug that in as your answer, right? Maybe it's a numerical response, maybe it's multiple choice. If I'm asking for exact values, I don't want decimals, I want an exact fraction. Okay, so here's where my calculator is really useful. What it's done is currently x, according to your calculator, means 0.66666. So until I ask my calculator to find something else, it will keep stored, or it will remember that x equals 0.666. And y? Your calculator remembers that y is equal to this. So until I find something else, these values are saved in my calculator. So I'm going to get out of this screen. And I can do that by going second quit. Second quit. And then I tell my calculator I would like to see X again, which is my variable button. So I press X, then I hit enter. Hey, that's the value I just had. And then from earlier in the course, I know I can get a decimal turned to a fraction. I go math, fraction, enter, and then I just have to say enter again to make my calculator go. Hey, it's 2/3. Okay. So there you go. The exact value is 2/3. And maybe you knew that one. Maybe you didn't need your calculator help, but that's okay. All right. Y is also stored somewhere, and we don't really use it that often, but we can find it. It's the alphanumeric. It's these green ones. So it's above the 1. So to get that, I press the green button. Alpha, Y, and I hit enter. Hey, there it is. And then I'm going to do the same thing. Math, fraction. So I hit enter, and then enter one more time. That as a fraction is 1/7, which I probably did not recognize on my own. So I'm glad I used my calculator to help me out. Okay. So in terms of this actual question, POI, point of intersection, is 2/3, 1/7. Or A is equal to 2/3, B is equal to 1/7. Those are the exact values to solve, and I did it simply by using my graphing calculator. I just had to rearrange. Okay, so using your graphing calculator, if it's already in y equals, we're good to go. It's super easy. If not, I have to rearrange to y1, y2, and then you just state your point of intersection. All right. It asks you to verify. I'm not going to do that, right? I would take the A value, plug it in, B value, plug it in, hopefully get a value of 5. And then I'd have to do the same thing over here. We're not going to do that. Okay, let's skip the verify on that one and get to some homework, which is right here, page 617, number 2, 3AC, 4AC, and then number 5. And that's it for today. And that is another video in the books using our graphing calculator to solve some systems. So today you have some homework, no check for understanding. I kind of switched up the typical schedule, and you can see that on the weekly schedule I posted. So this week, Tuesday and Thursday, we're going to have check for understandings. And then next week on Wednesday will be the weekly assignment. Just fit better and stretched out as we end the year here. So just some homework today. And then as always, fill out the Google form, send in your questions, set up a one-on-one appointment, whatever. Smash the like button, hit subscribe, and I'll see you guys next video.